So if you want to see the graph of this function, so here you have points, or you have three critical values. Have 0, plus, minus 1, but we see here it is 0. The function has no relative extrema. If we consider this one, for the function from minus 1 to minus 1 over root 2, it is concave down, then concave up, then concave down, then concave up. So we said here the function at 1, it has a relative minimum. From here, we said that at 1 it has a relative minimum. At minus 1 we have a relative maximum. So 1 minus 4 relative minimum, 1 4 relative maximum. So here we have 1 minus 4 relative minimum. Then we have minus 1 4 relative maximum. Then we said this function has inflection point at the point minus 1 over root 2, 0, 1 over root 2. So here we have 0, here we have minus 1 over root 2, then here we have also 1 over root 2. So also we have the derivative is equal to 0 at x is equal to 0, but there is no relative extrema at x is equal 0. So here we get this one, like this one, because here we have the derivative is equal to 0, but there is no relative. Now if you connect between these points, so here you have relative minimum, then here you have inflection point, another inflection point there, then you have relative maximum. This is the graph of your function f. Here we have another example, which is graph. Graph f of x is equal to cosine x minus cosine 2 of x. So to graph, we have to do all the 5 steps what we did it in previous section 4.6. So first, the domain of this one, since it is trigonometric function, so here the domain is from minus infinity to infinity. For the y-intercept, we need to put x is equal to 0. So y will be 2 cosine 0 minus cosine 2 multiplied by 0. This will give us y is equal to multiplied by 1 minus 1. So y will be equal 1. So the y-intercept 0, 1. For the x-intercept, put y is equal to 0. So 2 cosine x minus cosine 2x will be equal to 0. Then this will give us 2 cosine x is equal cosine 2x. If you use the calculator or any other program, you will find that x is equal 1 plus root 3 over 2, and x is equal 1 minus root 3 over 2. So we have 2 points of x-intercept. For the vertical and horizontal asymptote, for the vertical asymptote, for the cosine there is no vertical asymptote. For the horizontal asymptote, if you evaluate the limit when x approaches to infinity, this will give us infinity, and similarly when x approaches to minus infinity. So we conclude there is no vertical asymptote, there is no horizontal asymptote as well. Then for the symmetry, we need to check symmetry about the x-axis and the symmetry about the y-axis. The symmetry about x-axis, so we need to multiply the function by minus 1. So minus f of x, this will give us minus 2 cosine x, then minus multiplied by minus will give us plus cosine 2x. If you compare this function with the function f of x, it seems they are different, so it is not equal to fx. There is no symmetry about x-axis. For the symmetry about y-axis, we need to evaluate f minus x. So go to this function, replace x by minus x, we'll get 2 cosine minus x minus cosine 2 multiplied by minus x. We know that cosine function is an even function. That means cosine minus x is equal cosine x. So this will give us 2 cosine x minus cosine 2 of x. So this one, if you compare it with f of x, you will see they are identical. So that means the function symmetry about y-axis. So now to find the critical values, we need to find the first derivative. So we need to differentiate cosine, which is minus sine. For this one, derivative of cosine 2x, this will give us minus 2 sine 2x, because we differentiate as well 2x. So f prime x will be minus 2 sine x minus 2 sine 2x. Now, to find the critical values, we need to find f prime x is equal to 0. So f prime x is equal to 0 this will give us minus 2 sine x minus 2 sine 2x is equal to 0. So if you use the double angle rule for sine 2x, this will give us 2 sine x cosine x. So now if we take the minus 2 sine x common factor, from here you will left with 1, from here you will left with 2 cosine x. So either minus 2 sine x is equal to 0 or 1 plus 2 cos x is equal to 0. So from here x is equal 0 pi to pi. From here x cosine x is equal minus half, so that's mean x is equal pi over 3, 5 over 3, 5 pi over 3, and etc. So since there is no closed interval given, just we will I take just three values from here, also 2 values from here, but actually there are more values. So for the second derivative we need to differentiate this one. Derivative of minus 2 sine x will give us minus 2 cos x. Derivative of minus 2 sine 2x will give us minus 4 cos 2x. Derivative of sine, cosine, we need to differentiate 2x, which is 2. So 2 multiplied by 2, 4. So here we have the second derivative. We have here the critical values. These are critical values. We need to check the second derivative at the critical values to know if the function has relative minimum or relative maximum. So here we have the values 0, pi over 3, pi, 5 pi over 3, 2 pi, which is these values. Then I have here f double prime x. So I need to check the second derivative at the critical values. If it is positive, the function has relative minimum. If it is negative, the function has relative maximum. So here at x is equal to 0, the second derivative is positive. That means the function has relative extrema, and the value you substitute in fx by 0. So 2 cosine 0 minus 2 cos 0, this will give us 1. At pi over 3, the second derivative is negative. So that means the function has relative maximum. At pi, the second derivative is positive, so that means f has a relative minimum. At 5 pi over 3, the function is negative, so that means f has a relative maximum. At 2 pi, f double prime positive, so that means the function has a relative minimum. So we see that the function has relative minimum, then maximum, minimum, maximum, and so on. So since this one, the function is periodic, if you see here, so we have minimum at 0, at pi, and at 2 pi. So here we have at 0 minimum, then we have at pi, then we have at 2 pi. So the function has relative minimum here, 0, pi, 2 pi. Again here we have 3 pi and etc. And the function has a relative maximum at pi over 3, 5 pi over 3, and etc. So here we have relative maximum, another relative maximum, another relative maximum. Since this function is a periodic, we see that this function has no vertical asymptote, no horizontal asymptote. We write what is the x and y intercept. So here we have the x intercept. We take just 2 values. For the y-intercept, it is at the point 0, 1. So here we have the point 0, 1. This point represent 1 plus root 3 over 2 and 1 minus root 2 over 3, which is this one and this one. And then since our function is periodic, so it will repeat itself more than 1 times. So في الفانكشن هذه طبعا هي periodic، ما أعطانا فترة محددة. يعني لو أعطانا فترة محددة نحن نقدر نتوقف عند نقطة معينة هنا، بس بما أنه ما أعطانا وأعطانا فترة مفتوحة، هنا بس أنا أخذت اللي هي أول 3 قيم، وهنا أخذت أول قيمتين أو أول 3 قيم نفس الحالة اللي هي لحد هنا 2 باي. فلو كان معطيني مثلا from 0 to 2 باي، from 0 to 2 باي، بنتوقف طبعا عند 2 باي اللي هي عندي هنا نفس الحالة اللي هي، وعندي هنا اللي هي 0 from 2 باي. لكن بما أنها فترة مفتوحة طبعا أخذناها نحن مع أكثر من 0 to 2 باي، يعني هذا الرسمة حال أكثر من 0 to 2 باي. الفكرة بما فيها أن أول شي بنجيب الإكس والواي انترسبت، الدومين معروف مالها no vertical no horizontal. السيمتري طبعا ما في سيمتري about الإكس أكسس، حصلنا سيمتري about الواي أكسس، إذا معناته الجزء اللي موجود يمين الواي المفروض يطابق الجزء اللي موجود يسار الواي أكسس. طبعا على أساس إنه نجيب الكريتيكال نمبرز نجيب الديريفيتيف ونساويها بالزيرو. طلعنا الأرقام نجيب اللي هي second derivative. بعد ما نجيب السكند derivative نعوض اللي هي الكريتيكال فاليو في السكند derivative. إذا الناتج بوزيتيف إذا على طول نقول إنها relative minimum، إذا الناتج نيجاتيف إذا نقول عند النقطة الفانكشن عندها relative maximum. طبعا بعد ما نجمع المعلومات كامل يعطينا اللي هي هذه الفانكشن أو هذه الجراف.